In this lesson, you will learn how to verify trigonometric identities. Now, to begin this lesson, we need to talk about some fundamental trig identities. And then from these, we're going to use these to then prove different other trig identities. So starting off with the basics, we have learned in the past that we have sine, cosine, and tangent. And then we also learned that each of those has an inverse function. So the inverse function of sine, that would be cosecant. So cosecant, remember, is going to be 1 over sine. And vice versa. Sine would be the inverse of cosecant, so we have 1 over cosecant. Now with cosine, the inverse is secant. So secant equals 1 over cosine. So those are inverse functions. And then also cosine would be the inverse of secant, so we can write that as 1 over secant. And then we have the inverse of tangent, which is cotangent. That is equal to 1 over tangent. That's the inverse. And then the other way around is also true. Tangent is the inverse of cotangent, which would equal 1 over cotangent. So make sure you have these memorized. You'll need to know these. We also talked about tangent and cotangent being written in with sine and cosine. So another identity to have memorized is that tangent is equal to sine over cosine. And then cotangent is the inverse of that. So we can write cotangent instead of sine over cosine, we would write cosine over sine. So that would be two other identities to have memorized as well. Now a new one we're going to learn deals with the unit circle and Pythagorean theorem. So if you were to think of your unit circle, all right, so something like this, and you were to pick any angle measure. Let's say we pick this angle right here. So if you pick this angle and create this right triangle with that information, okay, the x value, so the x length over here, that is considered cosine. All right, and then the y value is sine. All right, so we've talked about that in the past. So you can almost think of, instead of x and y, we have cosine and sine. And then we can use Pythagorean theorem to find the hypotenuse, which actually we already know that, right? Because this is a unit circle, which means that the radius is 1. But with Pythagorean theorem, we would have this side, which is cosine. So cosine of this angle, we'll call it cosine of theta. Theta is the angle. Cosine of theta, we square that. We write that as cosine squared of theta. That means cosine times cosine. Plus, and then we take the other side of sine. So we have sine of theta and square that. So a squared plus b squared equals c squared, the hypotenuse squared, which is 1 squared, or 1. So we have cosine squared plus sine squared equals 1, or you can write that the other way around, where you have sine squared of theta plus cosine squared of theta equals 1. So now from those two, we can also develop some other identities. All right, so if we rearrange sine squared plus cosine squared of theta equals 1, so let's say we subtract the sine squared of theta to the right side, we can say that cosine squared of theta is equal to, and that would be 1 minus sine squared of theta. And then also if we take that original identity, and we subtract the cosine squared to the right side, we can say that sine squared of theta is equal to 1 minus cosine squared of theta. So if you have this first one memorized, you can derive these other two from that first one. Now with that first one again, we can derive some other identities from that. So I'm going to rewrite it down here to show you the work. So basically, we can develop two more from this. The first one is found by basically dividing everything, so both the left and the right side, by sine squared of theta. So let's do that. So let's divide everything by sine squared of theta. If you do that, notice what we get. Sine squared divided by sine squared is equal to 1, plus, and then cosine divided by sine is cotangent. So we have cotangent squared of theta equals 1 over sine squared of theta, and that would be cosecant squared of theta. So that's one other identity that we can have memorized as well. 1 plus cotangent squared equals cosecant squared. Now another one we can get from this is, again, if we take that original identity, sine squared theta plus cosine squared of theta equals 1, and we divide everything by cosine squared. So when you do that, what's going to happen, and we'll see it here, what's going to happen is sine over cosine would be tangent, so we have tangent squared of theta, plus cosine divided by cosine squared would be 1, equals 1 over cosine squared, that would be secant squared. So we have tangent squared of theta plus 1 equals secant squared of theta. So that's another identity that you can have memorized. And if you struggle with remembering those two, you can think through the thought process we just went through to develop this on your own, and then from here we can use that. So here we see a lot of different identities to have memorized. So here's 1, we have 2, 3, and then all these up here in the top left. Make sure all these are memorized. And then in addition to this, we have a couple more. And what we're doing for these ones is we're trying to figure out what do we get if we have the sine of negative x, or the cosine of negative x, or the tangent of negative x, and then also the inverse of each of those. So if we have the cosecant of negative x, the secant of negative x, and then the cotangent of negative x. So these ones, I personally like to not memorize. I just kind of think through the logic behind this to develop this on my own. And what I do, we can do is you can think through the unit circle, and x would be a positive angle. So like right here, think of this as angle x. So that's going in the clockwise direction. Negative x, a negative angle, means it's going to be down here with the same reference angle, but in the negative direction. So the question is, how does the negative angle, how do the identities of the negative angles relate to the positive angle? All right, so if you look at sine of negative x, okay, the sine, the value is going to be the same as far as the absolute value. Okay, it's going to be, maybe like 1/2 and -1/2 or something like that. But we know that up here in the first quadrant, sine is going to be positive. Down here in the fourth quadrant, sine is negative. So the signs are opposite. All right, so the sine of negative x is the opposite of the sine of positive x. And that is one of your identities to know. Now with cosine, okay, cosine of positive x and negative x, cosine is your x value, right? It's going to be over here on the right side. Anything on the right side is going to be positive. So for cosine, doesn't matter if it's x or negative x, cosine would be the same thing. It's going to be the same sign. So cosine of negative x would equal the same thing as cosine of positive x. And that's another identity to have memorized. Now tangent, we said that sine is positive up here, and cosine is also positive, whereas in the fourth quadrant, sine is going to be negative, and then cosine is going to be positive. All right, so if you're looking at tangent of negative x. So down here in the fourth quadrant, tangent would be sine over cosine, negative over positive, that's going to be negative. And then tangent up here in the first quadrant is going to be positive. So tangent of negative x is going to be the opposite sign. It's going to be negative as opposed to positive. So it's going to be the opposite of the tangent of positive x. And that's another identity to know. Tangent of negative x is equal to the opposite of tangent of positive x. All right, and then with cosecant, secant, and cotangent, it's going to be the same exact logic. Cosecant is the inverse of sine. So if cosecant of negative x is what we're looking at, it's going to be the same thing as over here with sine. It's going to be negative cosecant of x. And just like cosine of negative x was equal to cosine of positive x, secant of negative x would equal secant of positive x. And just like tangent of negative x equals negative tangent of x, cotangent of negative x is equal to negative cotangent of x. So these are other identities to make sure that you know. And again, I would suggest to memorize the logic behind it, because that's, in my opinion, much easier than trying to memorize 6 facts right here. And then right here we see the table that we have created with all of these identities put in together. So the ones here in the first row are called reciprocal identities. That'd be the inverse functions like sine and cosecant, cosine and secant, tangent and cotangent. And then over here, the second row, we call ratio identities, because tangent can be written as a ratio, a fraction. And same thing with cotangent. You could write that as a fraction. And then these other ones here, the sine squared plus cosine squared equals 1, and all the other ones that we see derived from that, that comes from the Pythagorean theorem, so we call those Pythagorean identities. And then the last one here would be called odd-even identities, because this is basically how we determine odd and even, was by plugging a negative x in place of x and seeing what we get. So these are called the odd-even identities. Now the terms aren't super important, but make sure you do have each of these memorized that we see here. So now that we have the basics down, we're going to use these to prove or try to prove other trig identities. Now when you're doing this, when you're trying to verify or prove other trig identities, we have some guidelines here that will be helpful. So again, each problem is going to be a case-by-case problem to look at, but here are some things to kind of look for. So you want to look for the more complex side, if there is one, and begin on that side, typically speaking. And then perform any sort of operation that's being said. So like if it's multiplication or addition or whatever, make sure you perform those operations. And then we can use our established identities, the ones we just showed, to help simplify. All right, and then another thing is if you see like secant or cosecant or tangent or cotangent or whatever, things like that, we can rewrite with just sines and cosines. And then from there we can maybe start canceling things out. Another thing is we can rewrite in terms of a single trig function. So again, we'll look at some examples of what that might look like, but you can try to simplify and combine into one. Another guideline we can use is we can multiply both numerator and denominator by the same thing, or by the conjugate of the numerator or denominator. So we can do multiplication in that manner to help get to our to verify the identities. And then just in general, keep the end goal in mind. So try to figure out where we're trying to go, see where we're trying to end up, and then think through a process to get to that point. So don't just do things blindly, but kind of see where we're trying to go with things. So now we're going to look at some examples to kind of get some ideas of how to use these different guidelines. So example 1, here we have secant of x minus tangent of x times sine of x equals 1 over secant of x. What we're trying to do is we're trying to verify this. We're trying to prove this to be true. So we notice that the left side is more complicated than the right side. So what we're going to do is we're going to focus on this left side over here and then try to rewrite this in different ways by using our different fundamental trig identities. In this particular case, we want to use the approach of trying to convert everything into sine and cosine. So secant, for example, secant of x, would be the same thing as 1 over cosine. That is the inverse of cosine. And then tangent of x, we learned, is equal to sine over cosine. So we have sine of x over cosine of x. All right, and then we have that multiplied by sine of x. Okay, so now from here, we can try to do some other things. Let's try to combine into one fraction. So we can simplify the left side, because notice the right side we need one fraction, right? So let's try to combine the left side into one fraction. So we have a common denominator already, so we can write this as something over cosine of x. We have 1 over cosine, so let's put the 1 here, and then minus sine of x times sine of x. We can put this into one fraction. Sine of x times sine of x would be sine squared of x. Now from here, we are getting closer, and remember, we mentioned with the Pythagorean identity, the sine squared of x plus cosine squared of x equals 1. We mentioned that we could rearrange this if needed. And here, if we rearrange by bringing the sine squared x to the right side, notice we'd have cosine squared of x on the left, then 1 minus sine squared of x on the right. So we see the squared in the sine. We can figure out, we might be able to do something with this Pythagorean identity. And sure enough, 1 minus sine squared of x can be replaced with cosine squared of x. So let's do that. We would write that as cosine squared of x over cosine of x. Okay, now from here, okay, cosine squared over cosine. We can simplify that. All right, we have squared on the top, 1 on the bottom. We can subtract the exponents. That would give you 1 cosine of x remaining. All right, now from here, we're basically done. We have to figure out, we have to get it to be 1 over secant of x, which cosine of x is equal to 1 over secant of x. So we have gotten the left side to be equal to the right side, 1 over secant of x. So therefore, example 1 has been verified. We have verified this identity. Let's try another example. Here with example 2, we have sine of x times 1 minus sine squared of x over cosine of x. Now, that's equal to tangent of x times cosine squared of x. Now when you look at this, the left side looks more complicated. We already have sine and cosine, so that's okay. This is sine squared. Whenever you see a sine squared, especially something like this here, we want to check to make sure if we can use the Pythagorean identity, this one right here. So if you rearrange this, as we did with example 1, if we subtract the sine squared of x over, that would give you cosine squared of x equals 1 minus sine squared of x. So that's going to help us because we can replace that with cosine squared of x. We see that right here. So we're just looking at the left side. We ignore the right side at the moment. We don't do anything with the right side. And then from here, okay, we do need to look at the right side to see where we're trying to end up. And what we can do is basically separate this fraction, right? Because we need tangent and cosine squared. We have cosine squared already. Now we just need the tangent of x. Well, if you write this as sine of x over cosine of x, take that, multiply it by cosine squared of x, and kind of separate it like we do here, we can write sine over cosine as tangent. So we have tangent of x times cosine squared of x. And that is exactly what we're trying to get to. That was the right side of that equation. So therefore, we have verified this identity. Okay, let's take a look at a third example. This example, we have secant to the 4th power of x equals tangent squared of x times secant squared of x plus secant squared of x. Now this one, there's a technique we can use. The left side is more simple in this case. The right side is more complicated. So let's try to take a look at the right side. Well, if we notice here, okay, we have two different terms. We have this term and then this term over here. Do you notice that they both have a greatest common factor? They have a factor in common. And they do. The factor in common is secant squared of x. So what I can do is I can factor the secant squared of x out, and then in parentheses put what is remaining. So secant squared of x times tangent squared of x would give you that first term, and then secant squared of x times 1 would give you secant squared of x for the second term. So we can write this as secant squared of x times tangent squared of x plus 1. Now this right here should be kind of ringing a bell as one of our Pythagorean identities. And we notice too, we're trying to add up to get secant to the 4th power of x. We already have secant squared of x, so all we need is another secant squared of x to get secant to the 4th power of x. And this here is actually one of our identities. All right, we've learned, we mentioned on the first slide, that tangent squared of x plus 1 is equal to secant squared of x. So again, it's important to have those memorized because otherwise you will not know that. But then from here, once we have that part, secant squared times secant squared would be secant to the 4th power. So now we have secant to the 4th power of x, which is the exact same thing as the left side that we were trying to get to. So therefore, we have verified this identity. Okay, let's try another example. Here's example 4. And this one's different because we have fractions now. And we have cosine of x over 1 minus sine of x equals 1 plus sine of x over cosine of x. So for this one, what we want to do is we want to take a look at either side. It really doesn't matter here because they're both, well, we probably want to look at the left side because this denominator, okay, what we can do is we can take that and we can multiply by the conjugate. So they're both about the same level of difficulty as far as the left and the right, but with the left side we can use the denominator and multiply top and bottom by the conjugate, which is 1 plus sine of x. We do that on the top as well. So when we do that, the numerator, we would have cosine of x times 1, and then plus cosine of x times sine of x. And then on the bottom, we would have 1 minus sine of x times 1 plus sine of x. We can distribute, and that would give you 1 minus sine squared of x. Now from here, we should identify the 1 minus sine squared of x as a Pythagorean identity. Remember, if we take the sine squared plus cosine squared of x equals 1, if we have that memorized, we can rearrange this by subtracting the sine squared of x to the right side. That would give you cosine squared on the left, and then 1 minus sine squared of x on the right. So we did that to verify, or to show you again, that 1 minus sine squared is equal to cosine squared. So now what we have is going to be cosine of x plus cosine of x times sine of x over cosine squared of x. Now to finish off, we notice that the top, both terms, both have a cosine of x, and the bottom has a cosine squared of x. We can divide everything by cosine. So if we do that, we would have 1 here. This would cancel, leaving you with sine. So we have 1 plus sine of x. That's a times sign. And then on the bottom, we divide out one of the cosines. That gives you just regular cosine of x. So now we have 1 plus sine of x over cosine of x, which is the exact same thing as we had on the right side. So therefore, we have verified example 4. Let's take a look at one more example. Here we have 1 over 1 minus sine of x plus 1 over 1 plus sine of x. And that's equal to 2 times secant squared of x. So to verify this one, notice the left side is definitely much more complicated than the right side. And what we can do is we can try to bring this into a single fraction. So to do that, we need to find a least common denominator, which would be 1 minus sine of x times 1 plus sine of x. So we do that for both fractions. We now write this with our new denominator. And then when we do that for the first fraction, notice that we had 1 minus sine of x. Now we also have a 1 plus sine of x. So we need to multiply the top by 1 plus sine of x as well. So we do 1 times 1 plus sine of x, which gives you 1 plus sine of x. Second fraction, we had 1 plus sine of x as our denominator. Now we also have included 1 minus sine of x with that. So therefore, we must also multiply the numerator by 1 minus sine of x. So we have 1 times 1 minus sine of x, which is 1 minus sine of x. And then from here, okay, the denominator, we can write this as a single fraction. We can rewrite the denominator because when you multiply this, that is the same thing as 1 minus sine squared of x. So you just FOIL that out. And then when you combine this into one fraction, the numerator, we would have 1 plus sine of x, and then plus the 1 minus sine of x. And we're adding that entire quantity. And then from here, notice the sine of x minus sine of x would cancel. That leaves you with 2 over 1 minus sine squared of x. And now, hopefully by now, the 1 minus sine squared of x is starting to stand out in your mind, because that is derived from the sine squared of x plus cosine squared of x equals 1 identity. You subtract the sine squared to the right side. So you rearrange this. You get cosine squared of x equals 1 minus sine squared of x. So 1 minus sine squared is equal to cosine squared. So now we have 2 over cosine squared of x. And then to finish off, 1 over cosine is secant. So 1 over cosine squared would be secant squared. And then 2 over cosine squared would be 2 times secant squared. All right, so we have the right side, the left side equaling the right side. So therefore, we have verified this identity. We have proven this to be true. Now, as we're wrapping up, a couple quick things to point out, and that is, first off, it's allowed, if you need to do some work on the left side and then also do some work on the right side and kind of meet somewhere in the middle. That is allowed, and you'll find that in some of the practice questions that may be beneficial. So if you get stuck on one of the sides and you know you can do some stuff on the other side of this equation, you can do that. All right, so that is allowed. Another thing is we did not do any examples with the negative x's, but just remember that if you see those, that you can replace, for example, like sine of negative x, you can replace that with negative sine of x. Or cosine of negative x, you can replace with the equivalent expression, which would be cosine of negative x equals cosine of positive x. So if you see those, you can replace it with these equivalent expressions, and that is okay as well. So, and again, each question is going to be a little different. Here we gave you some guidelines, some tools. We showed you some different ways that you might need to approach things. But again, each problem is going to be different, and we can't go through every single problem that you're going to encounter. But hopefully this gives you some tools. And that concludes our lesson for today. We will see you next time.